Hi guys, right, a very quick video here. I'm going to show you a couple of fault finding tips, you know, a couple of little secrets from the trade built up over many years. So here we have a 1970s hi-fi amplifier. Both output transistors were blown, quite a few other bits faulty as well. I've marked them all on the manual, the bits that were faulty. Now when you put all your bits in, there's a temptation to just put two new fuses and switch the thing on. Now that could be a disaster because you just miss one single part on there, and what's going to happen, as soon as you turn it on, you'll blow the new output transistors, which could be a disaster because in this case they were very expensive. So the tip for today is very simple. Is you've changed all the parts that you think were faulty, you've identified whatever you can. Instead of putting two new fuses in there, it was only one channel that's gone, replace both fuses with a couple of 5 watt 100 ohm wire wound resistors instead of the fuse. Now what'll happen here, we turn it on, and if there's still a fault on it, the current will be so seriously limited by the two resistors that we're not going to cause a catastrophe blow up in the output stage again. You're going to go, obviously, by measuring the volt drop across there, you can see something's drawing too much current, and the two resistors will limit the current while you're actually looking for the fault. So just to show you, I've got 200 ohm resistors instead of the two fuses. The current's going to be seriously the current will be seriously limited by these resistors. So if anything goes wrong, it's not going to blow up, and also there'll be enough current passing through the resistors to actually run this amp at low volume. So here we go, we'll switch it on. Now the little light flashing, that's the output stage DC detector. When it's checked there's no DC out in the output, it'll switch the amp on.
You should be ashamed of yourself. You must
and there you go.
Harmony there. The Mills Brothers was.
In fact, on reflection, it probably wasn't a song from Greece. It was probably that.
Well, anything you can get, you know, it doesn't have to be anything tremendous, but all first thing you saved up for, the first holiday you went on your own, first lie you ever told, first song you ever knew, first time you were ever on a stage, the first celebrity you ever met, the whole 19 subjects lay before us like a shoe with its lights on. What have you got over there, Peps?
Well, I can either...
So as you can see, 200 ohm resistors instead of the fuses. There's still plenty enough current passing to run this amp at low volume, so we can either leave it on soak test, we can either make more tests if it didn't work first time, and you're not going to cause any damage. It's not going to just blow up when you first switch it on. Okay guys, thanks for watching, and look out for the next tip. Okay guys, so here we've got Samsung microwave oven in repair. It's completely dead. I've checked it out and the internal fuse was blown here. Now there could be many reasons why the fuse was blown. It could be the door switches connected here, the safety interlock, one of them could be shorted out. It could be a fault on the control circuit itself, or it could even be, I've had in the past, the bulb blows and that blows the fuse. So the same principle applies. Don't just put a new fuse in, just pop out the fuse and put your 60 watt lamp connected across the fuse holder. That's it. Now a 60 watt lamp is limit the current so much that you won't be able to power the magnetron or the high voltage transformer, but it will allow you to test the safety interlock, the bulb, the operation of the control panel. So we've got 60 watt bulb across the fuse holder. I'll just plug it in, switch on, and as you can see, straight away it's come on. That means the control circuit's working, so the timer's working. The internal bulb you can see is lit up there, so it's not the bulb that's blown the fuse. We can test the safety interlock by opening and closing the door. Now, any problem with the interlock, if there was a sticking door switch or a welded together microwave, micro switch, this bulb would just light up rather than blowing your new fuse. So that's another quick test you can do with a 60-watt bulb before you investigate any further. Right, here's another tip. I've got the old fuse out of the microwave. It's a 10 amp medium blow ceramic fuse filled full of silica sand. Now what you need to do, don't just throw it away and put another one in. Get a pair of pliers, break open the old one and have a look inside it. If you can still see the fuse wire inside and it's intact, it's probably just burnt at one end or burnt in the middle, then the chances are the fuse is just blown as of old age. If you break it open and the fuse element inside is completely disintegrated, there's obviously been a dead short somewhere and it's going to need further investigation. So here we go, very carefully with a pair of pliers. And if you look at that, I'll zoom in with the camera. The actual fuse element inside the microwave is completely disintegrated. So that tells me that there's going to be more wrong with this than just the fuse, and it is going to need some more further investigation before we put a new fuse in. Right, okay, so continue with the fault finding. I've drawn a very basic representation here of how a microwave oven works. So you've got live coming in through a 10 amp fuse. You've got a switch there called the primary switch, and you've got another switch here which you'll notice is connected across the live and neutral. That's called the safety interlock switch. Now what happens is, when you close the door on the microwave, this closes, and at the same time this one opens, and it allows the power through to the high voltage transformer. Now quite often in microwave ovens, because these switches are carrying high currents, this switch here will weld together. Now that's a dangerous situation, because if that was welded together when you open the door and this is stuck together, the microwave transformer is still going to be powered and it's going to be producing microwaves, which is dangerous with the door open. So what the manufacturers do is these two switches, one opens and one closes. Now if that welds together while this switch is still closed, it puts a dead short across the mains, and that's what quite often blows the fuse. Now we've had a look inside the fuse and it's actually the element's disintegrator, so there has been a serious problem. So the next thing to do is take out the safety interlock switch. Now bearing in mind, in normal circumstances without a fault, this switch will never ever be used unless there's a fault. So what you do, the only clip together these is just pop it apart so we can get it on the camera. There we go, and if you take out the contact, let me see if I can zoom into this. Let's get the camera in focus. Now if you look at that there, that is actually burnt and black. So that indicates this switch here, that should never ever be used unless there's a fault, has actually operated. And the chances are it's the primary switch that's intermittently sticking. When we put a bulb across the fuse, this switch did open and close, but when it's passing a high current and it warms up, there's a very good chance it's going to stick together, and if that's stuck together when that's closed, that's what blows the fuse. So as you can see, we've actually found now the reason for the 10 amp fuse blowing, because that switch will almost certainly be sticky, or it's intermittently welding together. Okay guys, here we have the third and final tip, using the 60-watt light bulb. Now here I've got a Vestel TV. It came in because it was dead, the fuse was blown, the power supply is blown up. I've changed quite a few components here. It was probably caused by that little blue capacitor. But the last thing you want to do is just put, when you put all your new parts in, don't just put a fuse in and switch on and see what happens, because like I've said before, you just miss one thing or you get something wrong and all your new parts will be destroyed and it'll go off with a big bang. So instead of putting your fuse back in, replace the fuse with a 60-watt light bulb again. If you look there, you can see 2 crocodiles to the bulb across the fuse holder, and put your bulb across and then switch on. Now the first thing that's going to happen, and this can vary from set to set depending on how it's set up, if it's got PFC or not, the bulb will flash at least once while it charges up the HT reservoir capacitor. So here we go, I've got the bulb connected across the fuse holder. I'll hit the power down here and we'll see what happens. That's it, that's one flash from the bulb as it charges up the capacitor. Now the bulb is going to seriously limit the amount of current passing into the power supply, so we won't cause any damage if we get something wrong. Now there won't be enough current to actually run the telly to turn it on, but there will be enough current to run the standby power supply. So if we take a meter here, and bearing in mind this is still in, I'll put the test point there, which is the 5-volt rail for the standby power supply. And get the meter on. So there we've got 4.96 volts. So that indicates that the standby power supply is running okay. Right now, so everything seems okay so far. If you've got any other problem, this bulb would either light up continuously or you'd see some other indication that it's a problem. So just as a quick demonstration, it looks like this telly's ready to come on. It looks like we've got all the parts that were faulty. But just as a quick demonstration to show you how useful the bulb is, I'm going to put a dead short across there. I've got to be careful I've got to touch this because it's actually on. I'm going to put a dead short across the HT reservoir capacitor now with a 60-watt bulb in circuit, and we'll just see what happens. So I'll just turn off the power first and just stop the camera while I look for a crocodile clip. Right, okay, sorry about that, I found a crocodile clip now. So what I'm going to do, I've turned the power off to the TV. We're going to simulate a short on the power supply. That's the HT reservoir capacitor there. I'm going to put a crocodile clip straight across that. Oh, it's come off. Trying to hold the camera at the same time as doing this. That's a crocodile clip now. A dead short across the HT reservoir capacitor. And this time we're going to switch on and see what happens. So if you keep your eye on the bulb, and there we go, the bulb is continuously lit up. It's also very bright, and that indicates that there's a dead short on the power supply, or you've got another fault on the power supply that needs further investigation. But as you can see, and if you look down at the circuit there where the mains comes in, there is actually another fuse there which hasn't blown. So the 60-watt bulb has not caused any more damage on the TV. There's no big bangs. You haven't blown the bridge rectifier. You've not blown any more fuses. And there we go, guys. That's my third and last fault finding tip for this video. So if you just see if I can pull this off quick while it's still, the bulb's on. There we go, a couple of flashes as the set tries to power up, but the current's limited so it won't come on, and the bulb has gone back off again. So there you go, guys. That's the third and final tip for the video, and subscribe to my channel for some more. Thank you for watching.